Hi everybody, the purpose of this video is to go over the section part of section 2, lines and graphs. And in this part of the video we are going to go over the word problems associated in the homework. And instead of doing a PowerPoint presentation, we're actually going to go ahead and do the homework. So here is my assignment tabs for my MyMathLab version of 116. And if you'll notice that I've already done section 1. Homework 1.2a, and I got a 93, which is higher than a 70. So now I can go on and do section 1.2b. And here we go. Notice here we have 4 problems. So we have 4 word problems that we need to deal with. So let's go ahead and click on question 1 and see what we have. So in question 1, we have a plant that can measure 50 golf clubs per day at a total cost of $4,923. And then we have 7, and it can manufacture 70 golf clubs per day at a total cost of $6,223. Now, assuming that the costs of the production are linear related, we want to find the daily cost C of producing X golf clubs. So we're looking for, in part A, an equation that looks like this. C is equal to some slope, X plus B. Now remember, we can produce 50 golf clubs at a daily cost of $49 per day. So when X is 50, C is 4,923. So actually one of our points is going to be 50, 4,923. Another one of our points comes from here. Here we can produce 70 golf clubs at a total cost of $6,223. So our second point is going to be 70, comma, let me close that 70, $6,223. Okay, now this is looking like a point slope form type of a problem because we need to find the slope. We probably want to express it in slope intercept form, and we have 2 points. The point slope form, so we will have y minus y1 is equal to m times x minus x1. So we're going to need to compute m. Okay, so then we can use these 2 points to compute m. Remember, this can be point 1, so this would be x1, y1, and then this would be x2, y2. Okay, now remember, the slope from the slope formula, we have that m is equal to 6,223, y2, minus 4,923, divided by x2, which is 70, minus x1, which is 50. Okay, cool. Well, 6,223 minus 4,923 is 13,000. So here we have 1,300, my apologies, 1,300. Gave myself an extra 0 there. Divided by 70 minus 50, which is 20. And then if we do that calculation, we will have that m is equal to 65. We have a slope of 65. Okay, so with that, we can actually now use our point slope form. Now the question is, which point do you want to use? Do you want to use x1, and this should be y1, not y2? Or you want to use x2, y2. Now, even though it says x1 and y1 here, it doesn't matter. You can use either point and get the result you're looking for. But let's go ahead and use the first one. Okay, if that's the case, we are going to have y minus y1, which is 4,923. And that is going to be equal to m, or slope, which is 65, times x minus x1, which in this case is 50. Okay, well, we can use the distributive property here, and if we do, we are going to have 65 times x, which is 65x, minus 65 times 50, which is 3,250, And then over here, we still have y minus, I forgot the 50, and there should be a dollar sign, 4,923. Okay, now remember we want to solve for y now, and we can do that by basically adding 4,923 to both sides of the equation. So let's go ahead and do that. We're going to add 4,923 here. And we're going to add 4,923 here. Okay, when we do this addition vertically, these will cancel. We're going to be left with y is equal to 65x plus 1,673. Now, does this actually make sense? Well, remember, if this works, if this should work when x1 is 50 and x1 is 70. So let's try this when x1 is 70. So let's let x equal 70. And then we will have y is equal to 65 times 70 plus 1673, and that will be equal to $6,223. So it does check out. So we can just go ahead and put our answer in here, and that should be 65 times x, or 65x plus 1673. Let's hit enter and see what we get. Well, that's not going to work. That's 1973. Let's try 1673. And there we go. Good job. Now, they want you to graph the daily costs when x is between 0 and 200. Okay, now you don't need to graph it, but you did need to decide which graph is going to actually work. Now, the first thing is, notice here that we have y is equal to 65x minus 1673. So that basically means that the x-intercept must be between 1,000 and 2,000, a little bit closer to 2,000. Well, take a look at B here. B is only at, basically, the x-intercept is at the origin. This can't work. Okay, this one is out. Okay, so B is out. Okay, what about A? Well, let's take a closer look at A. For A, we have, well, first let's take out the divisions. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 divisions. So this is 2,000, 4,000, 6,000, 8,000, 10,000, 12,000, 14,000, 16,000, 18,000, 2,000. So this right here is between this right here is just below 2,000. So that actually might be the right mark right there. Let's take a look at C. C, once again, probably has the correct intercept. What about D? Well, D also has the correct intercept. However, we also know that when we have produced 50 clubs, the cost is going to be 4,900, pretty close to 500. Okay, remember this is, pretty close to 5,000. This is 2,000. This is 4,000. 5,000 is right around here. Once again, this is 20. This is 40. This is 50. So we have 2,000, 4,000. Right around here is 5,000. So that looks pretty close. What about, was that D? What about C? Okay, here is 50 clubs. That is 2,000. That is 4,000. That doesn't look right. So I think C is out. B is out. What about A? Well, for A, didn't want to do that. For A, when we have 50 clubs, 20, 40, 50, we are at 2,000, 4,000, 6,000, and right about there, which seems to be the value that you want to have if it is 70. So I believe that A is out as well. So the only thing we have left is D, which actually seemed reasonable when you first looked at it. We can probably look at it again. Once again, when we have 50,000 golf clubs being produced, we're pretty close to 5,000. So I am pretty sure that D is the answer here. Okay, I would be really embarrassed if it was done. And now we want to interpret the slope and the y-intercept of this cost equation. And remember, this is our cost equation. 65x plus 6,000 16,073. Well, and this is the y-intercept. The y-intercept is the cost per club, and the slope is the fixed cost. Well, I would say that that is false. First of all, the slope, the y-intercept is the fixed cost, and the $65 is the cost per club. Okay, the y-intercept is the fixed cost, and the cost and the slope is the cost per club. That kind of makes sense. So let's go ahead and click that. Let's take a look at the last one. The fixed cost and the cost per club sum to the y-intercept. The slope is the ratio of the two costs. That makes no sense whatsoever, so it is going to be that. And we can go ahead and click final check, and there we go. Okay, and then that is all we have for that particular one. And this brings us to question 2. And here we have that a farmer buys a new tractor for $157,000. And he assumes that it's going to be worth $82,000 after 10 years. That's their trade-in value. He also is assuming that the rate of depreciation is linear, that uses a constant rate of depreciation to determine the annual value of the tractor. And that basically means that the slope of the slope of the depreciation is going to be the same all the time, hence a linear equation. And the question here is find a linear model for the depreciated value, notice the value at time t after it was purchased. Okay? Well, once again, we actually have 2 points. And really the points that we're looking for are basically are the time that he's owned the truck and the value of the truck. Okay? Now, when he first bought the truck, the time was 0. The value of the truck was $157,000. So that is 1 point. Okay? When he's owned the truck for 10 years, that means that T is 10, then the value is going to be $82,000. So this seems to me to be a point slope type problem. So one of the things we need to do is go ahead and compute the slope. So once again, we are going to use the slope form, which is m is equal to y2 minus y1 over x2 minus x1. And I'm going to call this x1 y1. I'm going to call this x2 y2. And if I do, I will have that y2 is $82,000 minus y1, which is $157,000, and that is going to be divided by x2, which is 10, minus x1, which is 0. 82,000 minus 157,000 is going to be equal to negative $75,000. All right, divided by 10 minus 0, which is 10. And if you do the division, you will have that m is equal to negative 7,500. Okay, so that's our m. Now that we know our m, we can actually use our point slope form, which once again is y minus y1 is equal to m times x minus x1. And once again, it doesn't matter which point we use. However, this point right here might be the better one because it might be easier to work with because x1 is equal to 0. So let's go ahead and use that one. In that case, we are going to have y minus 157,000 is going to be equal to negative 7,500 times x minus 0. So we have y minus 157,000 is going to be equal to negative 7,500 times x. And then finally, all we need to do is add 150,700 to both sides. Actually, no, that should be 157,000. My mistake. So we're going to add 157,000 here, plus 157,000 here. These cancel. We have y. Over here we have negative 7,500 times x plus $157,000. And there you go. That should be your answer. That's when actually we're not dealing with x, we're dealing with t. So this should be negative 7,500 t plus 157,000. And let's see if I'm right. Okay, so with that, we can actually figure out the depreciated value of the tractor after 6 years. And that basically here, we just let t be equal to 6. And then we will have that y is equal to negative 7,500 times 6 plus 1,500, or 15,000, no, $157,000. Try to say that 3 times fast. And if you do that math, we will have $112,000. Okay, well, let's go ahead and see if that's right. Yes, it was correct. And then finally, they were asking us, when will the depreciation value fall below $500? In other words, when will $5,000, $50,000 be greater than, our equation here, this is supposed to be greater than negative 7,500 times t plus $157,000. Okay, well, what you want to do is you want to basically solve for t with this inequality, and the first thing we can do is we could subtract 157,000 from both sides. These cancel. 50,000 minus 157,000 is going to be negative $107,000. And that is going to be greater than negative 75,000, or negative 7,500 times t. Now we want to divide both sides by negative 7,500 to isolate t, so we're going to divide this by negative 7,500. And we're going to divide this by negative 7,500. So if that's the case, we are going, if that's the case, then we also need to go ahead and reverse our sign because we're dividing by a negative number. So we are going to reverse our sign, and it's going to be pointing in this way. Now when we do the math, these cancel, and that will give us 14.2667 is strictly less than t. Okay, and that basically tells us that when for the depreciation to become less than $50,000, t has to be greater than or equal to 14.2667, which means that this will occur in the 15th year. And there we go. Okay, now we need to go ahead and graph the correct. Now we need to go ahead and find the correct graph for this particular equation. Once again, this is the equation right up here. Okay, it is negative 7,500t plus 157,000. Notice here that the slope is negative, so that means that a is out. It also means, well, it basically means that a is out because a has a positive slope. The next thing we notice is that the intercept is 157,000. So let's take a look at this graph right here. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So the intercept is going to be at, this is 170. Well, let's actually move this over here. Actually, right there is fine. This is 170. This is 160. This is 150. This is 140. Here, the intercept is right around here. This is not 157,000. That is more. That's kind of, that's below 140,000. So this one cannot be it. So B is also out. It will have to be C, but let's just take a look at C to make sure. Okay, negative slope. The x-intercept, well, here is 170,000. Here's 160,000. Here is a good argument for 157,000. Okay, so it's negative slope. has the correct intercept. There is no other option, so I think C is it. So let's go ahead and pick C, do final check, and there we are. Okay, and then finally we have, oh no, not finally, here's question number 3. The birth rate of a certain country in 1995 was 15.2 births per thousand. In 2005, the birth rate was 14.96 births per second. Okay, so we want X to represent the years after 1995. Okay, so basically that tells us that 1995 is going to correspond to X being equal to 0. And if that's the case, 2005 corresponds to X being equal to 10. Assuming a linear relationship over this period, write a linear equation that relates Y in terms of X. Okay, where once again Y is the birth rate and then X is the year. So we have 2 points. The first one is going to be 0 because the year is 0. We have a birth rate of 15.2. Okay, and then at year 10, it's 2005, we have a birth rate of 14.96. And we want to come up with a linear relationship. Well, this, once again, we actually have 2 points, so this looks like it's the point-slope form, which can be written as y minus y1 is equal to the slope times x minus x1. Okay, so let's go ahead and compute the slope. The slope is going to be equal to y2 minus y1 over x2 minus x1. So let's call this x2 y2, this x1 y1, and let's go to work. Okay, so y2 is 14.96. y1 is 15.2, so minus 15.2. Okay, x2 is 10, y1 is 0. All right, 14.96 minus 15.2 is going to be equal to negative 0.24. Okay, and then finally, we have 10 minus 0. Well, that's just nothing more than 10. And now we can do the subtraction, and we will have that m is equal to negative 0.024. Now to do the point slope, now which point do you want to use in point slope form? Probably this one, so we can take advantage of x1 being equal to 0. So if we do, we are going to have y minus y1, which is 15.2. And that's going to be equal to negative 0.024 times x minus x1, which is 0. And there we go. So we have y minus 15.2 is equal to negative 0.024x. And then to finish the line, we just can add 15.2 here, plus 15.2 here. And then we will have these, and then if we add vertically, these cancel. And then we will have y is equal to negative 0.024x plus 15.2. And I made a mistake somewhere. Oh, I know where I made a mistake. I forgot the decimal point. Decimal point would be kind of useful. So let's put that decimal point in. Let's try this again. Much better. Okay. Now, part B is to estimate the birth rate at the year 2015. Okay, well 2015 is basically 20 years after 1995. 2015 minus 1995 is equal to 20. So in this case, x is equal to 20. So all we want to do is compute negative 0.024 times 20 plus 15.2. And that will give us 14.72. Now in the question, they want us to simplify our answer and type it as an interval or a decimal. Okay, so it doesn't look like we need to round, so we can just go ahead and put in 14.72. And there you are, you're done. Okay, let's go on to question 4. For some reason, this didn't go to question 4. I don't know why. Okay, well, here is question 4. Now, in question 4, we have an issue of a population of a country. So here, the population of a certain country per square mile of land area was 89. In 2000, the person per square mile population was 85.5. Assuming that the relationship between the years and persons per square mile is linear, we want to do two things. First is write an equation in slope-intercept form that describes the relationship between year and persons per square mile. Use ordered pairs of the form xy, where x is the number of years past 2000, and y is the persons per square mile. Okay, so if that's the case, once again, we're looking for an equation. We probably want to use the point slope form to do that, but first we want to express our two ordered pairs. The first ordered pair is going to be, which is x, is going to be the number of years past 2000, the year 2000. Well, in the year 2000, right here, we had 85.5 people per square mile. So, and since x is the number of years past 2000, in this case, x would be equal to 0, because 2000 is 0 years past 2000. And then our population at that time is 85.5. So this is 1 point. Okay, the next one occurs at 2007, which is 7 years after 2000. So in this case, x is equal to 7. And then the number of people per square mile in land would be 89. Okay, so those are our two ordered pairs. Now, once again, we want to use point slope, which is y minus y1 is equal to mx minus x1. Okay, and first to do this, we need to find the slope. So let's call this x1, y1. This is our first point. Call this x2, y2, and let's compute our slope. M is equal to y2 minus y1 over x2 minus x1. Well, y2 is 89 minus 85.5, and then in the denominator, x2 is 7, y1 is equal to 0. All right, now 89 minus 88.5, that should be, no, I'm sorry, 89 minus 85.5 should be 3.5. And then 7 minus 0 is 7, okay? And then 3.5 divided by 7 is equal to 1/2, or 0.5. Okay, so that's our slope. M is equal to 1/2. Okay, now we want to use the point slope form, and it doesn't matter which point we use. We can use this one or this one. We probably want to use x1, y1 because it has a 0 there, which will make this thing easier to work with. So using this point, we will have y minus y1, which is 85.5, and that is going to be equal to the slope, which is 0.5, times the quantity x minus x1, which is 0. All right, so cool. That gives us y minus 85.5 is equal to 0.5 times x. All we need to do now is add 85.5 to both sides, and then doing vertical addition, these will cancel. You will have y is equal to 0.5x plus 85.5. Okay, let's see if this works. I didn't notice, but the y equals is already there, so let me get rid of that. Here we go, that's a common mistake. Much better. Okay, now we want to use this equation to predict the population in 2030. Okay, 2030 is 30 years after 2000. Okay, 2030 minus 2000 is equal to 30, so x is equal to 30. So all we need to do is basically substitute 30 for x and see what we get. So we will have y is equal to 0.5 times 30 plus 85.5. Well, 0.5 times 30 is just 15. So this is going to be 15 plus 85.5, and that should be 100.5. And I was right. Who knew? And that is it. Those are all the 4 questions that you're going to have in the second part of your homework in section 2. And basically the questions you're going to encounter are just like these. Biggest thing here is there's going to be a whole lot of point slope form stuff in here, but they'll be just like these problems. The only difference will be the numbers. Okay, so don't use my numbers. You'll get them all wrong. You have to actually use your own numbers and then work the problems, and this at least will give you an idea of how to work them. And that is all that I have for this particular video. If you have any questions, please feel free to contact me. This is Bob Boyle, signing off.